uh-oh, we have a problem. And our problem is called scarcity. And this is because all societies have unlimited wants with limited resources. So we're going to take a look at something called the production possibilities curve in this screencast. And this production possibilities curve, or PPC, is a model. And this model will try to explain how there are trade-offs being made. And it will use words, there are going to be numbers, there's going to be graphs, which by the way, economists love graphs. And from these graphs, we can make generalizations. So I will probably call this a production possibilities curve, but I may call it a graph. You'll understand that it means the same thing, and that this graph will show us, and I will get to that in just a little bit, how it demonstrates scarcity, trade-offs, opportunity costs, and how efficient things are running or not. But you need to keep in mind that there are 4 key assumptions when looking at this particular model. And they are the following, and you can see them on the screen, but let me go over them just so that you have them in your mind. Is that we're going to see that there's only going to be 2 goods that can be produced, that there's going to be full employment of these resources, meaning we're going to be using them to the best of the ability that we can, that these resources are fixed, that's called ceteris paribus, and that the technology is going to be fixed when taking a look at these models. So let's take a look at one. So there's going to be 2 goods, remember, bikes and computers. And look at the table. We've got the following scenario, that if we are at point A in this particular society, we can make 14 bikes, but we cannot make any computers. But if we move to point B, you'll see that bikes goes down to 12, and now we can produce 2 computers. Starting to see a trade-off? I hope you are. If you move to point C, bikes goes down again to 9 and computers rises to 4, and so on and so forth. So in a sense, you're going to see that this table represents, once again, 2 goods, and it's the various combinations that these goods can be produced given that all of our resources are being fully employed. So we can put this on a graph. So let's take a look at what it looks like. So as you see here, points A, B, C, D, and E are plotted along this graph, and anything along that line, we're going to be calling that efficient, meaning every one of those combinations is possible. So in this particular society where bikes and computers are being produced, any one of those combinations is possible. Now, if I show you this point F, notice how it's inside this particular production possibilities curve. So it's inside it. So what do you think that might mean? Well, we're going to call that inefficient. Because if everything along this line is efficient, meaning you're using all of your resources to the fullest extent, but yet if you drop yourself inside this line, notice how you have lots of other potential resources that you could use. So that's what we're going to call that point inefficient. So something's happened in that economy, and we could use that, say it's unemployment, meaning people are out of work. Now, what if I show you this point on this graph, point G? Now it's lying outside the production possibilities curve, right? Because this is the efficient line. And remember one of our assumptions that we're using our resources to the fullest extent possible, but now we've got this point here. What could that possibly mean? Well, it's not possible. It's impossible because we don't have enough resources to get there. Okay? Now, if you recall, I mentioned that you can read a lot from these particular graphs, such as scarcity and trade-offs, and this concept called opportunity cost. Now recall, an opportunity cost is your next best alternative. Or in other words, what do you give up if you choose something? So let me give you an example. Let's take a look. Number 1, it says here, the opportunity cost of moving from A to B. Now remember, we want to know, what do you give up? So you were at 14 bikes, but you were at 0 computers. And if you move from A to B, that means you're going to give up something in order to get something. So we move from 14 down to 12 bicycles in order to move from 0 computers to 2 computers. So we gain 2 computers, but opportunity cost is all about what do you give up. So in this particular example, we are going to be giving up 2 bicycles in order to get 2 computers. So now I want you to take a moment and look at examples 2, 3, 4, and 5 and take a moment and see if you can answer them. So go ahead, hit pause right now. All right, let's check your work. So for number 2, the opportunity cost of moving from B to D. Once again, what do you give up in order to get something? So you were at 12 bikes, 2 computers, and if you're going to move all the way down to point D, what do you give up in terms of bicycles? So you go from 12, and that appears at about 5, so basically 12 minus 5 is 7. So you're giving up 7 bicycles. Number 3 says the opportunity cost of moving from D to B. Now all you're doing is just moving in a different direction on this curve, keeping in mind that you're thinking about what do you give up. So once again, you're at 6 computers and you're at 5 bicycles, and you're going to go from D to B. So you're going to be gaining bikes, but you're going to be giving up computers. So from D to B, you go from 6 computers down to 2 computers. So you're giving up 4 computers. Same with F to C. Interesting situation here, but let's go with it. So if you're at F and you go to C, notice here that you're not giving up any computers, right? Computers stay the same. And in fact, you're gaining bicycles. So in a sense, you're not giving anything up in this particular situation. So for instance, we know that in the scenario that I gave you previously, that if you're at a point F, that means that it's inefficient, meaning something's happened, perhaps unemployment. So perhaps by moving from F to C, we see a growth in the economy, that perhaps more people go back to work. So that means they can make more bicycles. Now, how about G? Hopefully you said the following. Hopefully you said that that was unattainable, because remember, that is a point outside our curve and we don't have the resources for it. All right, here's another example. This time, let's switch over to thinking about calzones and pizza. Calzone is a sort of like a pizza in that it's folded upon itself, kind of like this clip art shows here. It's got a crust and it's got, you know, your fine ingredients inside, your cheese, your pepperoni, your sausage, your onions, whatever it is that you like to put inside your calzone. And a pizza, as you can see on the right hand side here, is a pizza, right? It's flat and it's got slices and all the ingredients are on the top side of it. So a calzone, we have the two here, calzones or pizzas in this particular society. And at the various points, A, B, C, D, you'll see the different possible production combinations. So you could be at point A and you could make 4 calzones, but you can't make any pizzas. And if you go all the way to the end here, if you're at point E, you can make 0 calzones, but you could make 4 pizzas. So just like we did before, I'd like you to think about what the opportunity costs are, and they're from moving from point A to B, B to C, C to D, and D to E. So go ahead and hit pause now and calculate that. All right, let's check your work. A to B. You are essentially moving from 4 down to 3. And remember, opportunity cost is about what you give up. And you're giving up 1 calzone to make 1 pizza. To go from B to C, same idea. 3 down to 2. You're giving up 1 calzone to make 1 pizza. C to D, 2 down to 1. You're giving up 1 calzone to make 1 pizza. And the last one, D to E. You're giving up 1 calzone to make 1 pizza. I'm starting to sound like a broken record, but I'm trying to make a point. And you'll notice that that was a constant opportunity cost, right? And essentially that means it was 1 to 1. And that evidently, in this particular society, the resources were such that they could be easily adaptable. and they could make either one of those products. Now, that's really not very common, but you still need to understand that there is such a thing, and I wanted to show you that. And so what that means is that you'll see that it results in a straight line. All right, here's another example. Now we've got pizza and robots. You'll notice the table at the top. Take a moment and calculate the opportunity costs in this new example. Hit pause right now. Now hopefully you noticed that the opportunity cost was actually not constant in this example. In fact, it was increasing. So each time you moved from A to B, B to C, C to D, D to E, you noticed that you were giving up more and more pizzas in order to make robots. Now that's called the law of increasing opportunity cost. So as you make more of one good, the opportunity cost will increase. So that's telling us, as an economist, is that these resources are not easily adaptable to producing both of those goods. So pizzas and robots, that kind of makes sense when you think about it. So it will result in what's called a concave, or it's a bowed out production possibilities curve. Take a look at this example. Can you tell me which one is constant and which one has an increasing opportunity cost? Well, hopefully you identified the one on the left, the corn and the wheat. That's got the constant opportunity cost. You'll notice because it's got the straight line. And the increasing opportunity cost is the one on the right, cactuses versus pineapples, which really, when you think about cactuses versus pineapples, you can't grow both of those in the same area. So the resources would definitely have to be different. So we're going to move on, shifting that production possibilities curve. You might have been wondering to yourself, is it possible? Because we keep thinking about just two goods and same type of resources and no new technology, and well, we all know that that's really not possible and not really realistic in society. We know that things change. So we're going to look at it. We're going to look at, well, if there is a change, that there are things that actually can cause our production possibility curves to move, to shift, to be different. And that is that resources will change, like in quantity or quality, and that we may have a change in technology. So here's an example, robots and pizzas again. So what happens, for instance, if there is an increase in population? What would you expect to happen in this particular society? This would happen. We would see that the production for robots and pizzas, both things, would actually increase because we have got an increase in resources. Now let's take a look at this example. What if there is a technology improvement in pizza ovens? You have to think carefully about this one. It's pizza ovens. Do you think technology would impact robots? Hopefully you're saying no, because that's true. It's not going to impact the robots. Robots would stay the same. And it's the pizzas. That curve is going to shift out. So we've got some more practice problems. I'm going to have you draw a few things. You've got 6 different examples, and 3 of them have to do with pizzas and robots, and the other 3 have to do with pencils and calculators. So go ahead, hit pause, and draw these 6 curves, and when you're ready to check your answers, go ahead and hit play. All right, for question 1, it had to do with new robot making technology. Hopefully you shifted just the curve for robots because it does not impact pizzas. For question 2, we've got new pizza slicing technology. This particular production possibilities curve only impacts pizzas. So hopefully you showed the shift happening only for pizzas. For the third question, we had mad cow disease kills 85% of the cows. This might have been a little bit tricky, but you needed to take the leap that said that cows produce milk, milk produces cheese, cheese is used on pizzas, so therefore we had a reduction in our resources for pizzas. So you're going to see an inward shift for pizzas. All right, question 4 says that there's new pencil and calculator technology. Well, since it was new for both of them, you're going to see an outward shift for both. So the quality of the resources improves for both. So you're going to see that outward shift for both. Question 5 indicates that there's a significant increase in education. Same idea. We have an improvement in the quality of the resource, meaning the employees are better educated, therefore they can do their job better, and it's going to see an overall increase in the production of those two goods for that society. And the last one said that there are many workers that were unemployed and that there was a hint that the curve was not going to shift. And remember what that means is that it means that we fall off our curve of being efficient and now we are inefficient in this society because we have people that aren't working when they could be working. So our resources are not being fully employed. So that concludes this screencast. Go ahead and move on in this module.